So, yesterday I discussed about static and kinetic friction. So, I think now you might be having a better idea about what is static friction, what is kinetic friction. So, let's see more examples over it. So, what I will be seeing today means I will be showing today that will be a push and pull. Suppose this is your earth. Friction is there. Here also, this is your earth. Now a block is kept over it. A block of mass m is kept over it. Okay. Here also the block of mass m is kept over it. Now what I will be doing here, as I told you, the like what I will be doing here. Here I will be pushing it uh, like this. I will be pushing it with force F, and it makes an angle theta. Hmm. This angle is theta. Okay, so here I am pushing it, and here I am pulling it. I am pulling this block by force F, and same angle theta. So since the both the blocks are of mass m, so one mg force that will be acting downwards. Here also mg force will act downwards. Now when you are going to push it, the thing is that it's in equilibrium. It's in equilibrium means both these blocks are in equilibrium. So means there is no motion, no motion or no sliding or no sliding. It's in equilibrium. Both these cases, push and pull. So like there will be uh, friction force. One minute. The thing is that I told you normal reaction will also act in upward direction. So it will be like this here. It will be like this here. The friction force will be acting in uh, backward direction. So let's draw the friction force. Here it will be in this direction, friction force. This is the friction force F. S you can say. Why S? Static friction, because the thing is that body is there is no movement. If it's if the body is moving, that will be a kinetic friction. So here also same thing. Fs. Now let's do the component of this force. Like this force will be acting like this. Like this. I am extending it. This force will be like this. This angle will be theta. So along this direction, the component of this force will be what it would be? F cos theta. And along this direction, the force will be F sin theta. Same thing here. Along this direction, the force component is F cos theta. Along this direction, this force component is F sin theta. Now balance the forces. So you can see here like what N. N is balanced by mg and F sin theta. You can see here like N is balanced by mg and F sin theta. Vertical forces. So we can write here like N is equal to mg plus F sin theta. And what about horizontal? This friction force is balanced by this F cos theta, because there is no motion, no sliding, it's in equilibrium. So this F cos theta is equal to Fs. And as I told you yesterday, what Fs is? Fs is mu s n. In case of static friction, I told you Fs is mu Sn, where this mu s is coefficient of static friction. So let's substitute all these things. This will become F cos theta is equal to mu s n. Put this n over here. F cos theta is equal to mu s bracket में mg plus f sin theta. When we are going to substitute it, f comes out like this. Mu s mg over what it would be, cos theta minus mu s sin theta. Cos theta minus mu s sin theta. So this is the equation which we got from push part. Okay, this much of force we are going to apply, means this is the maximum force which can be applied on this block so that there is no motion. And let's see the pull part. So like here, balanced is n and f sin theta. You can see here that this f sin theta is upward, so it will be balanced by this mg. So the equation will be n plus f sin theta is equal to mg. What about horizontal forces? This fs will be balanced by f cos theta. So f cos theta is equal to fs. And what fs is? Same thing. Same thing. This. So we can write it like mu s n. Substitute this n value here. So it will become mu s what n will be mg minus f sine theta, and it will become f cos theta plus mu s f sine theta is equal to mu s mg. What f will be? So this will be mu s mg over cos theta plus mu s sine theta. So like you can see here, like we got these two forces, force values. So you can see here, like uh, so which one you see means which one you find is easier, means pushing is better or pulling is better. As you can see here, like pull force, this you can say this is what? This is pull force. And what is this one? This is what? Pull force, push force, sorry. It's push force. Here we are pushing. Here we are pushing this block so that it should start moving. It's not moving, but it should start moving. And here we are pulling. Here we are pulling this block. So this will be like here we got this pull force value and this push force value. But you can see like both these equations are very much similar. So you can see like both these equations you can see like means what would be the force value in case of pushing it and what would be the force value in case of pulling it. So like you can see like here is only one difference, like cos theta minus mu s sin theta. Here we have what? Cos theta plus mu s sin theta. Okay. So what you can say, which one is good? Means where you have to apply maximum force. The thing is that here this part, upper part is same, like this mu, yeah, this mu smg part is same. This mu smg part is same. Here also mu smg both have the same value. But the thing is here, this lower part, cos theta plus mu s sin theta, so that will be a big value, that will be greater than this one. You can say this cos theta minus mu s sin theta, because here we have cos theta minus signage here, but here we have plus signage here. So which one will be greater? That's you have to think which one will be greater. Think of your own. This you can say like here you have to apply more push force in comparison to less pull force. Okay, because you can see like here we have the minus sign, this value lower part will be less, here lower part will be more. So when lower part will be more, this pull force will be less, and this push force will be more. So means you have to apply much force while pushing in comparison to pulling. So you can say pulling is much more easier, means if you want to pull something, that is much more easier, means pulling is much easier than pushing. Pulling is easier than pushing, because in case of pushing you have to apply more force and in case of pulling you have to apply less force. So That's the main thing here. You can see here, like you can see all the things of your own by the help of this equation. Okay. So let's move to another part. Now let's see, there is one thing called angle of friction, denoted by lambda. So suppose this is your earth, and this is some block. So like here what will be? This will be Fs, and here will be normal force. So what would be the resultant force here? Somewhat like this. This would be the resultant of these two Fs and normal force. So this angle is angle of friction. It will be lambda. So what would be lambda? That we can say, like you can see, like this is for Fs and N. Like here if it's Fs, here if it's Fs. So what will be 10 lambda? That will be what? Fs over N. And what is Fs? Fs is mu s into N upon N. So 10 lambda h is equal to mu into s. So this is what is angle of friction. Now let's see what is angle of repose. Angle of repose. So suppose your blockage, suppose your block is kept like this on earth. So like I'm not putting anything, I'm not doing anything, it's in a state of rest and everything is it. The thing is that this suppose let me draw it in another way. uh, you like suppose some some uh, platform is here like okay, so like this part is fixed on earth, and this one is movable, and some block you can say is kept over it here. This one is fixed, mm, fixed on earth, and this one is movable, and some block is kept on this. Like here is some friction. I'm not applying any force, anything, nothing is applied on it. Now, after some means everything is fine. It's in state of equilibrium. Nothing is there. Now, what I am doing, this one is fixed, and now I started tilting it. Started because the thing is this one is movable. I started making some angle over it, and this block is kept over it. There is some friction. Remember, there is some friction. Friction is here. Friction is here. So this block is kept over it. There is nothing is happening. It's in very good means it's in state of rest. Here also it's in state of rest. Now it tilted means I increased this angle a bit more. Now this is that angle. Let me draw it first. Now this is that angle means if I am going to increase it a bit more than this angle, this block will start sliding down here. So it means that limiting friction will be acting in this direction. F limiting. I told you limiting, that is the maximum friction force after which the movement will start. Okay, so this means if I am going to increase a bit more than this alpha, this block will start sliding. So let's check out what would be the forces that will be acting like mg will be acting like this, and there will be normal reaction that will be acting like this. So let's break the mg into components, like it will be in this direction and in this direction. This one will be also be alpha, so this will be in this direction it will be mg cos alpha, and in this direction it will be mg sin alpha. In this direction it will be mg cos alpha, and in this direction it will be mg sin alpha. This one and this one. So like this is, I told you, this angle alpha means you can say it's the critical angle after which the sliding will start. So this angle is what is called the angle of repose. Okay, this is angle of repose. So let's calculate it. Like here you can see like there will be no, there is, you can say there is no movement. It's in state of rest, means uh, um, like it's in state of rest, you can say. But the thing is that if I am going to increase a bit more of the alpha, then that will be, it will start sliding. So let's balance the forces. Like what F limiting is equal to what, means I am going to balance the forces. This will be mg sine alpha, mg sine alpha. But the thing is that F limiting, I told you earlier what F limiting is. That is equal to what? Mu s into n. So we can write it like this. Mu s into n is equal to mg sine alpha. Now let's see another equation. What n will be? So n will be equal to, you can see like here, from here I am going to balance the forces. So this will be equal to, n is equal to what? Mg cos alpha. Okay, so we have these two equations. Do one thing, divide it. So what we have, when you are going to divide it like this, mu s n over n is equal to what? Mg sine alpha over mg cos alpha. Mg gets cancelled and n gets cancelled. So tan alpha is equal to what? Mu into s. Okay, so this is what is angle of repose. Okay, you can remember one thing, that there is no motion. This block is in state of rest. Okay, so I think that's all from the friction part. Um, and we will be discussing new thing in our next class. Okay, that's all for today. Thank you.